Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter D. Moivre's theorem, lecture number 10, in which I will solve some more trigonometrical problems. Now we solve a problem. Problem is, if 2 cos alpha equal to a plus a to the power minus 1, 2 cos beta equal to b plus b to the power minus 1, then prove that 2 cos p alpha plus q beta equal to a to the power p b to the power q plus 1 by a to the power p b to the power q. Now we solve this. Since given that 2 cos alpha equal to a plus a inverse implies that 2 cos alpha equal to a plus 1 by a implies that a plus 1 by a minus 2 cos alpha equal to 0 implies that here LCM is a, here a square plus 1 minus 2a cos alpha equal to 0 implies that a square minus 2a cos alpha plus 1 equal to 0 implies that this is a quadratic equation in which variable is a. Coefficient of a square is 1, coefficient of a is minus 2 cos alpha, and c is 1. So by quadratic equation a equal to minus b means here 2a cos alpha plus minus b square minus 2 cos alpha whole square minus 4a means coefficient of a square 1 and c is 1 multiply 1 by 2a. A is here coefficient of a square 1 and this is equal to 2 cos alpha plus minus square root 4 cos square alpha minus 4 by 2 implies that a equal to 2 cos alpha plus minus, here we take common minus 4, 1 minus cos square alpha by 2. This is equal to 2 cos alpha plus minus square root minus 4 sin square alpha by 2. This equal to 2 cos alpha plus minus, this is 2i sin alpha. If we square this, we will get minus 4 sin square alpha by 2. Here 2 common, cos alpha plus minus I sin alpha by 2. This equal to cos alpha plus minus I sin alpha. If we take a equal to cos alpha plus I sin alpha, then 1 by a equal to 1 by cos alpha plus I sin alpha, and this is equal to cos alpha plus I sin alpha whole to the power minus 1, and by de Moivre's theorem this equal to cos minus alpha plus I sin minus alpha. Cos minus alpha is cos alpha and sin minus alpha is minus sin alpha, minus I sin alpha. Let this is 1, this is 2, this is 3. Similarly, we may get B equal to cos beta plus I sin beta, and 1 by B equal to cos beta minus I sin beta. This is number 4 and this is number 5. Raising power P in both sides of 2 and 3, we get a to the power P equal to cos alpha plus I sin alpha to the power P equal to cos P alpha plus I sin P alpha. Let this is number 6, and 1 by a to the power P equal to cos minus alpha plus I sin minus alpha to the power P implies that 1 by a to the power P equal to cos minus P alpha plus I sin minus P alpha by de Moivre's theorem, and this equal to cos minus theta equal to cos theta, this equal to cos P alpha minus, since sin minus theta equal to minus sin theta, so here minus I sin P alpha. This is number 7. Again, raising power Q in 4 and 5, we get B to the power Q equal to cos Q beta plus I sin Q beta. This is number 8, and 1 by B to the power Q equal to cos Q beta minus I sin Q beta. This is number 9. Now a to the power P, B to the power Q. A to the power P is cos P alpha plus I sin P alpha. B to the power Q, here 8, cos Q beta plus I sin q beta. And using the concept of de Moivre's theorem for the product of two factors is cos p alpha plus q beta plus I sin p alpha plus q beta. This is number 10. Now 1 by a to the power p b to the power q equal to 1 by here cos p alpha plus q beta plus I sin p alpha plus q beta. This is equal to cos p alpha plus q beta plus I sin p alpha plus q beta whole to the power minus 1. And by de Moivre's theorem, for negative power, we get here cos minus 1 multiply p alpha plus q beta plus I sin minus 1 multiply p alpha plus q beta. And this is equal to cos minus theta equal to cos theta, cos p alpha plus q beta, sin minus theta equal to minus sin theta. So here minus I sin p alpha plus q beta. This is number 11. Adding 10 and 11, we get a to the power p b to the power q plus 1 by a to the power p b to the power q equal to cos p alpha plus q beta plus I sin p alpha plus q beta plus cos p alpha plus q beta minus I sin p alpha plus q beta. Here this term and this term cancels. So this equal to 2 cos p alpha plus q beta. Proved. Now we solve the next problem. Next problem is if a equal to cos theta plus I sin theta, b equal to cos phi plus I sin phi, then prove that a cube by b cube plus b cube by a cube equal to 2 cos 3 theta minus phi. Now we solve this. Since given that a equal to cos theta plus I sin theta implies that a cube equal to cos theta plus I sin theta whole to the power 3. By de Moivre's theorem, this is equal to cos 3 theta plus I sin 3 theta. This is number 1, this is number 2. Again, given that b equal to cos phi plus I sin phi implies that b cube equal to cos phi plus I sin phi whole to the power cube. By de Moivre's theorem, this is equal to cos 3 phi plus I sin 3 phi. This is number 3. This is number 4. Therefore, a cube by b cube equal to cos 3 theta plus I sin 3 theta by cos 3 phi plus I sin 3 phi, and this will be equal to cos 3 theta plus I sin 3 theta, and we write this cos 3 phi plus I sin 3 phi to the power minus 1, and this equal to cos 3 theta plus I sin 3 theta. By de Moivre's theorem, for negative power we get here cos minus 3 phi plus I sin minus 3 phi. Now we use the de Moivre's theorem for the product of these two factors equal to cos 3 theta minus 3 phi plus I sin 3 theta minus 3 phi. This is number 5. Similarly, b cube by a cube equal to cos 3 phi minus 3 theta plus I sin 3 phi minus 3 theta. We may write this as cos minus 3 theta minus 3 phi plus I sin minus 3 theta minus 3 phi, and this equal to cos minus theta equal to cos theta, cos 3 theta minus 3 phi. Here sin minus theta equal to minus sin theta. So here minus I sin 3 theta minus 3 phi. This is number 6. Adding 5 and 6, we get a cube by b cube plus b cube by a cube equal to here cos 3 theta minus 3 phi plus I sin 3 theta minus 3 phi, here plus cos 3 theta minus 3 phi minus I sin 3 theta minus 3 phi. This term and this term cancels. So this equal to 2 cos 3 theta minus 3 phi. This equal to 2 cos 3 common theta minus phi. Proved. Now we solve the next problem. Next problem is find the general value of theta which satisfies the following equation. Cos theta plus I sin theta multiply cos 3 theta plus I sin 3 theta multiply multiply cos 2r minus 1 theta plus I sin 2r minus 1 theta equal to 1. Now we solve this by using the concept of de Moivre's theorem. Left hand side equal to cos theta plus 3 theta plus 2r minus 1 theta plus I sin theta plus 3 theta plus plus 2r minus 1 theta. This is number 1. Since 1 3 comma 2r minus 1 are in AP, arithmetic progression, in which first term equal to 1, common difference equal to 2, last term equal to 2r minus 1. Since we know that last term equal to first term plus number of terms minus 1 into common difference D. Let first term equal to A, common difference is D. Let number of terms equal to n. Therefore, last term equal to 2r minus 1 equal to first term is 1 plus number of terms n minus 1 common difference D equal to 2 implies that 2r minus 1 equal to 1 plus 2n minus 2 implies that 2r minus 1 equal to 2n minus 1 implies that n equal to r. Therefore, number of terms equal to r. Therefore, theta plus 3 theta plus plus 2r minus 1 multiply theta equal to theta common 1 plus 3 plus plus 2r minus 1. This equal to theta. Here sum of r terms, number of terms is r, and we calculate this by the formula number of terms by 2 bracket 2 into first term is 1 plus number of terms minus 1 into common difference D 2. This equal to theta multiply r by 2. Here 2 plus 2r minus 2. This is theta multiply r by 2 multiply 2r, and this is r square theta. This is number 2. Therefore 1 may be written as cos, sum of these terms is r square theta plus I sin r square theta. This is left side and this will be right side, and right hand side is 1. Implies that cos r square theta plus I sin r square theta equal to 1, means 1 plus I into 0. We may write this cos r square theta plus I sin r square theta equal to cos 2n pi plus I sin 2n pi. 2n pi, cos 2n pi equal to 1 and sin 2n pi equal to 0. n belongs to z, set of integers. Z be the set of integers. Implies that r square theta equal to 2n pi. N belongs to z, set of integers. Implies that theta equal to 2n pi by r square. N belongs to z, z be the set of integers. Therefore, our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.